Example question 20. The velocity as a function of time for a car on an amusement park ride is given as v equals at squared plus bt with constant a equals 2.0 meter per second cube and b equals 1.0 meter per second squared. If the car starts at the origin, what is its position at t equals 3 seconds? So here in the question, we have the velocity function v, which is a t squared plus bt. And I have the value of a and b, which I can substitute in the velocity function as v equals a is 2 t squared plus b is 1 t. Then they said that the car starts at origin. Starting at origin means initial position x0 of the car will be 0 meter. We need to find what is its position at t equals 3 seconds. So I need to find what is x at t equals 3 seconds. Now when they give you position function, and if they ask you to find velocity from position, or if they give you velocity and they ask you to find acceleration from velocity function, we take derivative of this term to go from position to velocity to acceleration. But when you have to go opposite, that means from acceleration when you go to velocity, or from velocity you go to position function, then you do integration. So if I have velocity function as given to me in the question here, and I want to find position from that velocity function, I have to integrate the velocity values to find x. So that is what I'm going to do here. We will find the position x as integral v dt. We will integrate the value of velocity function to calculate the position values. So I write integral 2.0 t squared plus 1.0 t dt. Now the first step to integration is to identify all the powers of t. So here I have power of t as 2, and in the second term I have power of t as 1. The second step you do in integration is increase the power of t by 1. So for the first term, I will write 2.0. I will increase the power of t by 1. So 2 plus 1 will become 3. For the second term, I will write 1.0. Again, I will increase the power of t by 1. So 1 plus 1 will give me 2. After you increase the power of t by 1, then you divide each term with the new power. So I'm going to divide this term with the new power, which is 3. And I will divide this term with the new power, which is 2. So this is the three-step method we do for integration. First, identify the power of t in each term, then increase the power of t by 1, then divide each term with their new power, and then add the constant x0. Now, in order to find the value of position at time t equals 3 seconds, I'm going to substitute t as 3 seconds in this expression here. So we get x equals 2.03 cube by 3 plus 1.03 square by 2 plus x0 is the initial position, and since we are starting at origin, initial position is 0. And when you solve this, you get position at time t equals 3 seconds to be 22.5 meter. So whenever you have velocity function v and you need to find position from that velocity function, you will have to take integration of v to find x. Example question 21. The speed v of an automobile moving on a straight road is given in meters per second as a function of time in seconds by v equals 4 plus 2 dq. Calculate how far has the automobile traveled in the interval between t equals 0 and t equals 4 seconds. So here in this question, again, we have the velocity function v, which is given as 4 plus 2 dq. I need to find how far it has traveled. That means I need to find the value of x between the time interval of t1, I will write as 0 seconds, to t2, which is 4 seconds. Now, when they give you definite values of time over which you need to find the distance traveled, we have to use definite integration. So again, if we have velocity and I want to find position, I have to integrate the value of velocity to reach x. And since we have been given two time values, I will use definite integration. So we write x as x equals integral v dt, and I will take this integration over time values t1 and t2. Now substitute. Integral t1 is 0, t2 is 4, v is 4 plus 2t cubed dt. So we follow the same steps to integration. First, identify the power of t for each term. Here I have just 4, which is a constant. And whenever you have a constant, the power of t for those constant will be 0, t to the power 0. And the second term, the power of t is 3. After identifying the power of t, I'm going to increase the power of t for each term by 1. So the first term becomes 4 t to the power 1 plus the second term becomes 2 t to the power 4. Increase the power of t by 1. After you increase the power of t by 1, now divide each term with the new power. So I divide this by 1 and I divide this by 4. And we solve this over the same interval of time 0 to 4. Then I will simplify this and write 4t plus cancel 2 and 4. You get 2 here, half t to the power 4, and the limits are 0 to 4. Then we solve for x by substituting the limits. You have to do upper limit minus the lower limit. That means first, wherever I have t, in place of t, I will substitute the value of upper limit, which is 4, minus wherever you have t, now you will replace that t with lower limit, which is 0 over here. So let's substitute. I will write 4 times t. In place of t, we will write 4 plus half 4 to the power 4 minus 4 times 0 plus half 0 to the power 4. Now, when you substitute for lower limit, make sure the whole term is inside a bracket or make necessary changes to the sign because of this minus sign over here. And when you solve this, you get the value of x as 144 meter. So this is how far the automobile has traveled between the interval from t equals 0 to t equals 4 seconds. Example question 22. An object starts from rest and has an acceleration given by a equals bt squared minus half ct, where b is 2 meter per second to the power 4 and c is negative 4 meter per second cube. Calculate the object's velocity after 4 seconds. So here in the question, they have given us that it starts from rest. Now, whenever an object starts from rest, its initial velocity will be 0. The velocity at that point will be 0. So I write my initial velocity v0 to be 0 meter per second. Then I need to find its velocity after 4 seconds. So we have to find the value of v after time t equals 4 seconds. I have the acceleration function given as a equals bt squared minus half ct. And we have the value of b and c, which I will substitute here. A equals b is 2 t squared minus half. C is negative 4 t. And when you simplify this, you can write a as 2 t squared plus 2 t. The minus and minus here becomes plus. 4 divided by 2 will give you 2. So I have the acceleration function and I need to find velocity. So when we go from acceleration to velocity, I have to integrate the acceleration function to find velocity. So we will take integration of acceleration to find v. We write v as integral a dt, which will be integral of 2t squared plus 2 times t dt. So we follow the same step of integration. First, we identify the power of t for each term. For the first term, it is 2. For the second term, it is 1. Then we increase the power of t for each term by 1. So raise the power of t by 1. 2t cubed plus 2t squared. After you raise the power of t by 1, divide each term by the new power. So here I will divide by 3. Here I will divide by 2. Then we can simplify this term if we can. So 2 by 3 t cubed plus 2 and 2 cancel. That gives me just t squared plus v0. Now when you do integration, we always have to add a constant c at the end. And for us, the constant is the initial value of the function that we are finding. So if I'm finding velocity v, my constant c will be the initial velocity v0. Now we substitute the value of time t to calculate velocity after 4 seconds. So we substitute t as 4 in this function here. So we write v equals 2 by 3 t, which is 4 cubed plus 4 squared plus v0 is 0. Solve for v and you get velocity after 4 seconds to be 58.67 meter per second. Example question 23. A plane starts at rest on a straight runway. For the first 15 seconds, the plane's acceleration alpha is given as a function of time by the equation alpha equals beta t squared, where beta equals 1 over 90 meter per second to the power 4, and t is in seconds. What is the plane's speed at t equals 15 seconds? So here we have been given the acceleration function, and this time the acceleration function is written as alpha instead of a. And I write alpha equals beta t squared, where beta is 1 over 90 meter per second to the power 4. So I will substitute that alpha equals 1 over 90 t squared. And initially the plane was at rest. At rest means its initial velocity v0 will be 0. We need to find what is the plane's speed. That means the final velocity v, or the final value of speed v after time t equals 15 seconds. So again, we have to integrate the acceleration value, because if I'm finding velocity from acceleration, I have to integrate the acceleration function with respect to time t. So we write velocity v equals integral a dt, which is integral 1 over 90 t squared dt. Then we follow the steps of integration. The power of t here is 2. I will first increase the power of t by 1. So we get 1 over 90 remains as it is. Increase the power of t by 1, it becomes t cubed. Then divide by the new power, so divide by 3 plus v0. After this, we substitute the value of t to calculate final v. So we get v equals 1 over 90 times t, we will substitute as 15 seconds. So 15 cubed divided by 3. v0 is the initial speed, which is 0. So plus 0. I get my final speed after 15 seconds to be 12.5 meter per second. So please remember, while solving problem based on position, velocity, or acceleration function, if you start at position and you need to find velocity, or acceleration, you have to take derivative of position to find velocity and derivative of velocity to find acceleration. So when you move in this direction, we take derivative. But when you go opposite, when from acceleration, you have to find velocity, or from velocity, you have to find position x. In this situation, we take the integration of the function. So I will integrate acceleration to find velocity, and I will integrate velocity to find position.